Hello, this is the tutorial for experiment 9, molar solubility and common ion. So you did a titration with saturated calcium hydroxide using HCl. So if you were in lab, the concentration was 0.05013. On the board it may have said something different, but make sure it's 0.05013 for this particular section. I think I wrote 0.5013, so make sure you correct that in your calculations. So for the volume of saturated calcium hydroxide, if you use the analytical pipette properly, you will have delivered 25.00 milliliters of the saturated calcium hydroxide solution. And for each of the titrations, hopefully your values were within range of each other and not too crazy different. So hopefully you didn't have 22 mils and then 26 mils for titrations. So these are actual values from a student. So they were around 22 milliliters. Yours may have varied slightly, and that is fine. So and then for part C, I have the values here as well. Again, you're using 25 mils. This is the calcium hydroxide with calcium chloride, and you may have seen less volume that it took to get to the endpoint than above. So for calculating and determining the hydroxide concentration, you first want to find the number of moles of HCl used, and that is your number from up here, so your total volume of HCl that was used, the 0.02189 liters, and then you're multiplying it times the molarity of HCl. So if you calculated this properly, you will have gotten 0.001097 moles. So that's the number of moles of HCl. And then the moles of HCl is going to equal the moles of hydroxide because they're a 1-to-1 ratio. So again, this is 0.001097 moles. And you determine the concentration, you have to divide it by the volume. So you delivered 25 mils, or 0.02500 liters. So when you divide that, you get your value in moles per liter, and that will be 0.04388 capital M, or moles per liter. So that is your hydroxide concentration. To determine the calcium 2+ concentration, that same thing is 1/2 of OH minus. So 1/2 of OH minus is 1/2 of the 0.04388 we just calculated. So for calcium, that should be 0.02194 molar. And then to get to the molar solubility of calcium hydroxide, that is the concentration of calcium in the ions. So that's 0.02194. And then to calculate the KSP, or for the average mole solubility, you're going to determine the OH and calcium for all of the trials, and then take the average of all your calcium. For KSP, it's a concentration of Ca2+ times OH squared. So that's 0.02194 times 0.04388 squared. So the KSP for me is 4.224 times 10 to the negative 5th. All right, and then to determine the Part D calculations, your calculations are identical. You have determined the OH using HCl, so the HCl used is 0.01669 liters times the concentration of HCl. So we have 0.0008367 moles. So moles of HCl, moles of OH. So again, this is 0.0008367. And then you divide it by the 25 mils, or 0.025 liters. So that's your molarity. And then calcium equals 1/2 of OH minus. So that's your concentration of calcium. And then the molar solubility is equal to the concentration of calcium. So it's 0.01674. And again, to do the average, you just have to find the values of all of those.